So I'm going to make a series of videos on calculus, but particularly with the use of Python programming. For most of the applications, I'll be focusing on the use of the module SymPy. So just to get started, who am I designing this for? Anybody who's interested in learning calculus. The focus really is on calculus. The material here does not assume any background in programming. You don't have to know it, and you don't actually have to use any of the programming that I show while we're going through this, but it's helpful if you want to play with it on your own. There are a number of decent calculus resources that are already available. Khan Academy and Paul's Online Notes and a few other resources have their own virtues, and on several of those virtues I will not be able to improve, but I will go ahead and say that what makes this unique that might make you interested in this rather than the other resources available are that I do try to maintain a level of mathematical rigor. So I actually go through the proofs, and that just means that it's a little bit more difficult, right? It's not necessarily designed for an engineer, although an engineer might find it useful, but it's particularly useful for somebody who might be planning on majoring in mathematics, because I actually describe and explain the proofs. Now, although I don't shy away from difficult things like proofs and hard problems, I also try to present all of the material in as intuitive a way as I possibly can. I try to make everything have some kind of a physical or meaningful sense. So I try to take hard things and make them simple. Obviously, one of the big things that sets this apart from other calculus resources is that I throughout make very frequent and intense use of software, namely through Python, to illustrate. I solve several exercises, so this is unlike Paul's Online Notes and Khan Academy, is that I give many solved problems. And also, one of the virtues of this is that although you won't really be learning a programming language per se, you'll definitely be getting a lot more familiar with Python if you're not already familiar with it. So it's kind of a nice opportunity to at least kind of be in the presence of a programming language and to use it up to a point without actually studying a programming language or computer science per se. So to begin with, what is the Python programming language? It is, I think, one of the easiest programming languages there is to learn. It's also increasingly has become a very practical programming language for fast computation, used in industry, used in finance, used in a lot of different contexts, so that not only is it very easy to learn, it's also really becoming a very practical tool for industry and whatnot. So how do you get it? Well, I recommend getting the Anaconda package. So Google or search however you want. Install Anaconda, follow the first link or two, and follow its instructions. It will install a fairly large but very useful collection of tools that many of which run behind the scenes that just make everything work smoothly. Once you have it, it may have pinned a launcher or a navigator to your taskbar or desktop. It will probably have an icon that looks like this and loads up, and you'll have the Anaconda launcher, is what I have, although I've also seen it called the navigator. And once it loads eventually, you'll click on an icon that looks like this. It's called Spider, and that's a IDE, an integrated development environment. So that just lets you write code in an editor. When you run the code, it will print to the console down here. So it just makes programming a lot easier. And then, so now that's how you get Spider running and you're ready to get started with programming in Python. I'll just say a few words about the SymPy module. Whenever I'm programming in Python, I will almost always, if not always, import SymPy. And this is a module that allows you to interact with mathematical objects in a symbolic way. So, you know, how is that distinct from the contrasting concept of numerical methods? Numerical methods have all of these, you know, decimals, and it can be somewhat messy and hard to really glean the message that that you're supposed to be getting from the numbers. So symbolic Python is you know, able to store something like square root x, where x is just a variable, right? It actually kind of understands the concept of variables, which, you know, you couldn't do through purely numeric methods in quite the same way. So, so it is symbolic, and therefore the emphasis is on the concepts. We will be using the SymPy module to evaluate functions, to solve equations, to graph functions. We can use it like a calculator, and there are several other ways in which we'll be using SymPy. So there you have it.